So good morning. We are going to study one of the most important topic or the heart of this course, that is concept of stability. I will do very slowly. I want all of you to understand this, and I'll give you some problems in between. You have to do it, and the entire exercise should be over in 40 minutes. That is the idea. So let me tell you about stability. I'll go in detail about stability in the part 2. So we say a system is stable if we give a bounded input, the output is bounded. That is, in very simple words, if you give a small input, if the output is small, we say it is stable. For example, if you go and hit someone, if you hit you back, that person is stable. Okay. If you hit someone and if you kind of beat you to pulp, then the person whom you are hitting is not unstable. Okay. So on a lighter side. So let us study this very formally and very slowly. Okay. I want all of you to understand this. Okay. Both from examination point of view as well as the idea of the subject. Okay. So some of the things I have already told you, I'll repeat it. So in this particular class, we learn about poles and zeros. I have said informally many times. Here I'm going to make it very formal. Then one thing which I haven't said very specifically is about S-plane. Okay, I'll be talking about S-plane. Then open loop transfer function and closed loop transfer function, you should not get confused about it. So you should read the question, you should read the context and understand clearly. Then closed loop pole, that is the main thing. Okay, if you know closed loop poles, you know a lot of things about the system. Okay, then characteristic equation. So many things we can analyze using characteristic equation. Then relation between closed loop poles and characteristic equation. This particular line I edited many times because the relation means they are one and the same. Okay, the closed loop poles are the same as the zeros of the characteristic equation. So let us formally define poles. You know transfer function. So if the transfer function, you should always get back to the physical field. There may be a system, electrical, motor, aeroplane, power system, whatever it is, you can get a transfer function. So transfer function is ns by ds, a numerator polynomial by denominator polynomial. So s is a complex variable. Okay, we'll come to that slowly. So if the transfer function could always be expressed as ns by ds, then what are poles? Poles of the transfer function correspond to values of s at which the denominator polynomial ds is equal to 0. So whenever ds becomes 0, this transfer function will become infinite, it will blow out. Then that we say as poles. The value of s at which the transfer function blows out becomes infinity, we say they are the poles. And what are zeros? Correspond to the values of x at which the numerator polynomial ns is equal to 0. So at zeros the transfer function will become 0. So let us consider this very toy example. I have told you earlier, find the poles of the transfer function. So the transfer function is 10 by s plus 1 into s plus 2. Poles means denominator should be equal to 0. S plus 1 into s plus 2 should be equal to 0. That means s equal to minus 1 and s equal to minus 2. When s is equal to minus 1, the denominator is 0. When s is equal to minus 2, then also the denominator is 0. So these problems you should do. Okay, find poles of the transfer function. 3 questions are there. Try to do this. Okay. So this is the new thing, or S-plane. So whenever you find poles and zeros, you have to plot in the S-plane. So S-plane has 2 axes. The real axis or the sigma axis. This is sigma axis, real axis, and there is an imaginary axis. This is called imaginary axis, or it's called the j omega axis. So whenever you find poles and zeros, they are complex numbers. So in a very lighter, in a very easy way, you can think of S-plane as the complex plane. All of you know how to represent a complex plane represent a complex number in a plane. Real number you can represent it on a line, okay. And complex numbers, to represent complex number we want a plane, okay. Say a complex number could be 1 plus j2. So you take 1 here, you move along this line 1 and go up. So this point will be what? 1 plus j2. Similarly, this point will be what? This point will be 1 minus j2. That means all of you know, all of your engineering students, this should be very clear. But what you should know is S-plane is the complex plane, and we will be seeing a lot about S-plane. So let us move forward. Let us consider another example. Consider the system with transfer function Gs equal to s square minus 2s plus 5 divided by s plus 1 into s minus 2 into s minus 3. Find poles and zeros of the transfer function and mark it on the S-plane. So the first part is easy for us. Zeros of the transfer function are the roots of the equation numerator polynomial equal to 0. So zeros means what? Zeros means this numerator s square minus 2s plus 5 equal to 0. When will this become 0? So you can find the root of this s square minus 2s plus 5 equal to 0. You find the root of this equation. All of you know from your school days, minus b plus or minus root of b square minus 4ac by 2a. You will get this as 1 plus j2 and 1 minus j2. And what are poles of the transfer function? Poles of the transfer function is given by the denominator equal to 0, ds equal to 0. S plus 1 into s minus 2 into s minus 3 equal to 0. Therefore, what are poles? Poles are minus 1, minus 2 and 3. So whenever you are for exam or anywhere, you should read the question carefully. Mark it on the S-plane. So this is the S-plane. So I have marked it on the S-plane. You see the zeros are marked with a small 0, okay, small circle. So this convention I want you to understand. That is one reason of repeating all these things again, okay. Zeros, whenever you are marking zeros, you mark it with a small circle, okay. Where's my hand? My hand is not visible, okay. It's interesting. Mark it with a small circle, okay. So that is zeros, and poles you will mark it with a cross. You will mark it with a cross. You can see a cross here. I'll use this color. You mark it with a cross. So let us find poles and zeros. We have found in the zeros are 1 plus j2 and 1 minus j2. It is marked here, 1 plus j2 and 1 minus j2. Poles corresponds to numerator equal to 0, and zeros corresponds to numerator equal to 0, and poles are denominator equal to 0. We have seen it as minus 1, 2 and 3. So where is minus 1? This is minus 1. You can see this small cross here, minus 1. Then plus 2. Plus 2, I put a small cross. That is how we mark poles. So this is standard convention. Please follow it. So mark poles. So this is mentioned without any qualifier. For pole we have saying poles of the transfer function. Okay. So now let us go to closed loop systems. So in many situations we may be wanting to find the closed loop transfer function. So that is why we gave this question for the series also. I have mentioned it before also. Once you have a transfer function like this, we have the forward transfer function Gs and feedback transfer function Hs. Then the overall transfer function for this closed loop system is Gs by 1 plus GsHs. And what are closed loop poles? Closed loop poles corresponds to denominator equal to 0. So closed loop poles corresponds to the denominator polynomial equal to 0. So what is the denominator polynomial? This is the denominator polynomial, and this polynomial is called the characteristic polynomial. This polynomial is called the characteristic polynomial. It's very important. And if I equate it equal to 0, we call it as characteristic. We call it as characteristic equation. So 1 plus GSH is equal to 0 is called the characteristic equation. And what are the roots of the characteristic equation? They are nothing but the closed loop poles. So that is why characteristic equation is important. Okay. So if you know GS, if you know HS, you can find characteristic equation. If you have a complicated system, the denominator polynomial equal to 0 is called the characteristic equation. Here there is a very simple example. GS is 1 by S, HS is 1 by S plus 2. You are asked to find the characteristic function. Given GS is 1 by S, HS is 1 by S plus 2. So characteristic equation is 1 by 1 plus 1 plus 1 by S into 1 by S plus 2. If I take the LCM, it will become S square plus 2S plus 1 divided by S into S plus 2. So this is equal to 0 when the numerator is equal to 0. So characteristic equation, we normally will not say S square plus 2S plus 1 divided by S into S plus 2 equal to 0. We will say the numerator of that function to be 0. So the characteristic equation for this system is S square plus 2S plus 1. And closed loop poles will be, you solve this, S square plus 2S plus 1 equal to 0, you solve it, you will get the closed loop poles. So we will do one problem. The open loop transfer function of a unity feedback system is 2 by S square plus 2S plus 2. Find the closed loop transfer function. B, open loop poles. C, closed loop poles. How will we do this? Let us think for a while. Closed loop transfer function is GS divided by 1 plus GSHS. GS is given here. GS is given here. HS is 1. Why? Because unity feedback system. So I can find closed loop transfer function. Let us do one after the other. So given GS is open loop transfer function 2 by S square plus 2S. It is given in the question that the system is a unity feedback system. Therefore HS is equal to 1. So what is closed loop transfer function? GS divided by 1 plus GSHS equal to 0. GS is 2 by S square plus 2S. 1 plus GSHS is what? 1 plus 2 by S square plus 2S. If you take LCM of the denominator will become, this term will become what? S square plus 2S plus 2 whole divided by S square plus 2S. And the numerator also is 2 by S square plus 2S. So both S square plus 2S will get cancelled and we will get the closed loop transfer function. What are the open loop poles? Open loop poles corresponds to the poles of the open loop transfer function. So 2 by S square plus 2S could be written as 2 by S into S plus 2. So the denominator will become 0 when S is 0 or when S is equal to minus 2. What are closed loop poles? We know the closed loop transfer function. Closed loop poles are nothing but the point where S square plus 2S plus 2 become the denominator of the closed loop transfer function becomes 0. Closed loop poles are the roots of the characteristic equation, and characteristic equation is what? S square plus 2S plus 2 equal to 0, and so minus b minus 2 plus or minus root of b square. What is b square? 2 square minus 4ac, 4 into 2 minus 8 by 2. So 4 minus 8 is what? Minus 4. Minus 4 is root of minus 4 is minus j2. J2. All of you know that root of minus 1 is j. So the closed loop poles are -1 plus J1 and -1 minus J1. So I wanted to finish this so that you'll get time to do some problems, okay, at the end. So I will tell you the reason for this later on. I will tell you an anecdote, okay. When I was young, I went for one short-term training program. Our college sends us to learn new things. So it was on robust control, and I saw one person who was madly in love with the control system. Whenever he talks like this. He talks like this. What is this? This is his S-plane, okay. He will talk about S-plane and poles and zeros, okay. It happened some 25 years back, okay. I still remember. Why S-plane is so important is because if the closed loop poles have negative real part, the system is stable. So you find all the closed loop poles. If all the closed loop poles are having negative real part, then the system is stable. And this could be put in another way. System is unstable if there is at least one closed loop pole with positive real parts. You have a system, a 10th order system, all 9 poles are negative, are having negative real part, and one pole is having positive real part, then the system is unstable. So let me draw a S-plane here. So this I told you, this is our S-plane. So this part, this is the negative, any point here will have negative real part. So if the poles are on the left half, then if the poles are having negative real part, or if poles are on the left half of S-plane, we say the system is stable. This is a problem. Find closed loop poles of the following second order system with closed loop transfer functions given below. Comment on the stability. Here closed loop transfer function itself is given, okay, and you have to comment on the stability. I'll tell you another story, okay, of my friend. I'm sad about it, okay. I had one friend, he used to read maths and learn it, okay. So what happened is we all had fun, we studied, and we passed out of the college in 4 years, okay. So the poor, my friend, he was intelligent, okay. He was maybe in the top 10% of the class, okay. So he used to read problems, okay. He never does problems, okay. So the sad part is he didn't clear many subjects when we completed at the end of the 4 years. We were all sad about him. We used to support him. We used to help him. Some students, some of our classmates who were in Trivandrum used to help him with doing problems and clearing papers. So 5, 6 students were having back papers, okay. Then after 1 year we forgot, okay, about him, okay. We were all in different parts, okay. Then the sad part is I saw him when I joined TKM as a young faculty. He was so tired of writing exam in College of Engineering Trivandrum because he was feeling ashamed to go and write exams with his junior. So he came to CET to write an exam. It was very hard for him to meet me, okay. So I don't want that to happen to you. So please do the problems, okay. They are very easy problems. So they're very easy. So in my first take I didn't explain this problem. So it's so easy, 2 by s square plus 2s plus 2. How will you find closed loop poles? Closed loop transfer function itself is given. So equate denominator equal to 0. Then solve it, you will get closed loop poles and mark it on the S-plane, okay. One more problem. And you have to comment on the stability. If the poles are complex numbers, if all the poles are having negative real part, system is stable. If one of them is having positive real part, system is unstable. So that's all. Thank you.